In this example, you're seeing some similar types of problems that you saw with power functions when we were talking about them in the previous lesson. And here, they're still all vertical transformations, and they're going to work in a very similar way as they did when we were talking about them with the power functions. We have this original function, f of x equals x squared, which is your very most basic quadratic function. And you're asked, okay, well, what would each one of these look like? If you're vertically stretching f of x by a factor of 2, that means you're multiplying all the y coordinates by 2, which means you're multiplying f of x by 2. And if you're multiplying f of x by 2, that's 2 times x squared. So that's what the formula is going to be here. H of x, by vertically compressing f of x by a factor of 1/3, means you're multiplying all the y values by 1/3. So you're going to have 1/3 times f of x. Now, there's different ways you could write that because multiplying by 1/3 is the same thing as dividing by 3. So you're going to have x squared divided by 3, which you could also write as 1/3 times x squared or x squared divided by 3, more like this way. So any of those would be acceptable as an answer for that. And here j of x is created by vertically stretching f of x by a factor of 4. So you're multiplying by a 4, but because you're reflecting the result across the x-axis, this is concave up. That's going to cause this to be concave down. So it is flipping it, which means that this is going to be a negative 4 instead. So you're going to do negative 4 times f of x, and negative 4 times f of x would be a negative 4x squared. For this one here, you have this format here, which is more of a transformed form. It's also known as vertex form. The vertex form is called that because this tells you what the vertex actually is. Because if you look at the vertex form for a quadratic function, the number that is next to the x in the parentheses tells you about the x coordinate. So the vertex here is going to be at h comma k. The value outside here is going to be the y coordinate of the vertex. Pay attention to the fact that this is a minus here. So if you're not seeing a minus inside the parenthesis, that means that if you have a plus here instead, that means that you're going to have a negative value for your h. It's always going to be like a different sign, whereas this is going to agree with signs. So here you can see that your h is 2, your k is a negative 3, so that's what the coordinates of the vertex are. The a value tells you about whether it's concave up or concave down, and therefore whether it has a minimum or a maximum. If this value on the outside of the parenthesis is positive or greater than 0, it's going to be concave up. If it's less than 0, it's going to be concave down. Any parabola that's concave up is going to have a minimum at the vertex. Anything that's concave down is going to have a maximum at the vertex. So here, when you look at this, there's a negative 9 here. That means that this thing is concave down, which means that the vertex is 2, negative 3 is actually going to be a maximum. So the highest value you're going to have is negative 3 on this particular quadratic function. And so that is the end of this example, and that is the end of this video. If you have any additional questions, please bring them up during class.